Hello everyone. Now let's take one more example to understand the conversion of NDFA to DFA. So let's take a language L in which the second symbol from right hand side is A. So in the previous example, we have taken a language in which the second symbol from left hand side is A. Now we have taken a language from in which the second symbol from RHS is A. So what are the possible strings available in this language? The possible string is AA, BAA. So you count the second symbol from right hand side. From right hand side it is A, it is A, it is AAB, here right, second symbol, and so on. That means the language is infinite. So for this infinite language, first you have to draw the transition diagram. Transition diagram of language L in non-deterministic finite automata. So A is the initial state. On A, you will accept any number of A's or B's. After that, I will accept a small a and goes to the state capital B. And finally, after reading one more small a or small b, I will reach final state capital C. So C here is final state. Okay, this is the transition diagram for this language. Understood? Now if you draw the transition table, in the column there are two input alphabets A and B, and in the row there are three states. One is initial state indicated by arrow symbol, second is the non-final state B, and third is the final state capital C indicated by star symbol. Okay. Now for input alphabet small a, and if you are on the state capital A, then what are the transitions we have taken? On capital A, if you see A, you will go either capital A itself or go to the capital state capital B. So here there are two states for input alphabet small a and B. Okay, and we represent them in a curly braces. Okay. Now for input B, the capital A goes to capital A itself. So here the state is capital A. Similarly, for capital B state, we have to find the transition for input alphabet A and input alphabet B. So for input alphabet A and B, it will go to the state capital C. Okay, and what about the final state capital C? On final state, there is no movement defined here. So we can write here phi. Phi represent the dead configuration. Okay. Now for this NDFA, I want to draw the DFA transition table as well as DFA transition diagram. For this, I will use subset construction method. Okay. In subset construction method, first I will start the first row. Okay, so first row is initial state capital A and the two input alphabets small a and small b. Okay, so on capital A, the moves are AB and A. So here square brackets is used to denote the two merger states. So here you can call it as a single state, but this single state is denoted under the square bracket symbol, and here the move is capital A. Okay. Now we have covered the capital A state. Now we want to find the capital AB as a whole. So the next row is capital AB. Okay. This example is very much different from the previous two examples. In the previous two examples, we have achieved only a single variable as a state, but here two variable is combined as a state. Okay. So whenever the two or more variables combined as a state, then you will union their transition modes. So here AB is considered as a single state, and if you union them, then this will be ABC. So you will get ABC as a transition, and here if you union them these two, then you will get AC. Okay. So AB is also over. Next is ABC and AC. You can choose any one of them. Let's say I will choose first AC, because I want to complete the two different variables as from one, and then after I will cover the three variables at one. So on AC, what you will do here is pick A as a state and C as a state and union them. A, B and phi. What will we get here? We will get AB as a single state. And here also A and phi. If you union them, then you will get A as single state. Okay. Here also you can write them in a square bracket. Okay. Now AB is covered, A is also covered, ABC is left. So let's take ABC. So ABC, union them all the three states, you will find that on a small a you will get ABC, and on a small b you will get AC. So AC is also covered, ABC is also covered. So I think I have covered all the states in DFA. So in DFA, you will get four different states. Okay. Now let's draw the transition diagram. So what I will do here is I will just erase this side portion. You will note it down, and after that I will draw the transition diagram. So this is DFA transition diagram. A is the initial state, and what is the final state in this particular transition table? In the previous NDFA portion, C is the final state. So here AC is final state and ABC is final state. Okay. So on A, let's say AB. Okay. So capital A seeing A will go to the state AB. Capital A on seeing B will go to itself A state, and capital AB on seeing small a will go to state capital ABC. Okay, and on small b it will go to the state capital AC. So on small b it will go to the state capital AC. Okay, so these two are over. Okay, now capital AC on a small a, capital AC on a small a will go to state capital AB. So it will go to state capital AB, and on a small b it will go to the state capital A. On a small b it will go to the state capital A. This is also over. Capital ABC state on seeing a small a will go to capital ABC itself, and on a small b it will go to capital AC state. So this is the final transition diagram for the language, in which every second symbol from right hand side is A. Okay, so you should be very careful while drawing the transition table as well as transition diagram using subset construction method. Okay, so in the next video we will see a new concept in TOC.